Hello, everyone. We're going to work through station 2 of our vectors unit and practice with some application word problems. Okay, so problems 1 and 2 are pretty similar to one another. They're both based off of a ramp. Okay, and so you'll see that they have a little bit of a similar structure, but we are just solving for different pieces here. Okay, so we have a force of 576 pounds, which is required to pull a boat and trailer up a ramp inclined at 12 degrees. Find the combined weight of the boat and trailer. Okay, it's a little bit tricky, but don't think of the boat and trailer as separate pieces. They are actually just a single item. Okay, so here is my ramp. Okay, it has a 90-degree angle here and a 12-degree angle there. Okay, and atop here is my boat slash trailer right there. Okay, now the thing to note about these is when you draw a ramp diagram, the diagram is actually backwards because we're not solving a problem on the ramp, we're actually solving the problem on this triangle right here that I'm drawing. Okay, which is again a right triangle, and it has the weight as the hypotenuse and your force as the side across from it. So what we will do is we will then redraw this as the triangle that we want to solve as the vectors that are more useful to us. Okay, so in this form, we see this. The vector is always the weight of the object, okay? And then the two component sides are like this, okay? And this side right here represents the force to pull it, okay? Now, it's more like geometry than it is vectors at this point, but this angle is the same as the angle we saw in our original diagram. It is 12 degrees, okay? So in this case, I also know that my force is 576 pounds, okay? And I'm gonna solve for my weight. So if we solve this, it is gonna come out something like this. We will have sine of 12 degrees equals 576 over x, right? Where x is our weight of the objects combined, okay? And so if you solve this, you multiply by x and you divide by that sine, you get something like this. X equals 576 over sine 12 degrees. And it should tell you that x equals 2,770.41 pounds. Okay, and that will be your solution for this one. The key thing to remember is the weight is always the hypotenuse or the resultant overall vector, and the vertical component is the force required to pull your object. Okay, the horizontal component also represents a physical quantity, but that's more of a physics question. I don't want to go down that rabbit hole right now. So let's go ahead and look at the second problem. If you can, go ahead and set it up in a similar fashion. Okay, and so you can see I quickly made a sketch here of the ramp with the 200-pound cart on it. Okay, and the ramp has an incline of 30 degrees. Now, again, start by redrawing this. Okay, remember, these diagrams for ramps are not accurate to what you want to do with your vector. Okay, so if I draw this, remember, the hypotenuse, the long resultant vector, is going to be my weight. So this side right here is 200. That is my weight. Okay, and I'm going to solve for this component of my vector, which represents the push or pull. Okay, and so let's set it up and solve it. Remember, this angle right here is, again, that same 30 degrees. These two triangles are similar. They're different sizes, but the same shape. Okay, so we have something like this. Sine 30 equals x over 200. If you solve this, you should get x equals 100 pounds. Now, the first two problems in here were based off of ramps, and now the next two are based off of completing work. Now, work follows a pretty straightforward formula for us, and as long as you kind of follow that, you should be pretty safe doing this, okay? The basic idea of work is just that um, work only actually applies to the distance that an object travels combined with the force in that actual direction. So if you put an angle on the force, not all of it is being applied. So here's our basic setup for a work problem. We're going to do force times distance times cosine theta. Okay, pretty simple as long as we just fill in the information correctly. So from here, I'm going to go ahead and plug this in. We got 40 pounds of force times 50 feet of distance times cosine 30 degrees. And if you just go ahead and plug that in your calculator, it'll give you the 1732.05. And this is in foot pounds. Okay. So foot pounds being the number of feet you traveled against the pounds that you put into that, right? The cosine is adjusting for the fact that the force you were putting in was not actually all going into the work. You can solve the next problem the same way. Go ahead and try it if you want, and then otherwise you can see my setup in just a second. So you can see again, I went with force times distance times cosine theta. And then again, we just go straight to our calculator. We'll plug this in. Make sure that you are specifying that you are in degrees using that degree symbol. 91 feet pounds again, okay? Foot pounds representing, again, a combination of distance and force, and they have to move in the same direction. All right, so that is our application problems for vectors using ramps and work as some useful examples for you. Good luck and happy studying.